We're going to talk a little bit about the density of the Earth and the density of the different layers within the Earth. When the Earth was first created, it was this very hot ball of liquid material that you and I are not used to seeing in a liquid state. In our normal life, we see it in a solid state. But when it was a liquid, what happened was the lighter things, the things of lower density, floated to the top, and that is the crust of the Earth. The crust of the Earth is the portion of the Earth that you and I are familiar with. This is the mountain ranges and the valleys and the trees and where your house happens to be. That all occurs on the crust of the Earth. Below the crust of the Earth is something which is called the mantle. The mantle is made of rocks, more dense, stronger, tougher rocks than the actual crust. Below that is a outer core of the Earth, which is liquid. And how do we know it's liquid? We know that this outer core is liquid because of that seismic earthquake data that we have gotten. The actual interior of the Earth, the center, is solid. And that is solid nickel and iron. So the center of our planet is made of a lot of metals, and the exterior of our planet, the outside, is made of the rocks, the same sort of rocks you pick up lying around the road. Now, I've been using the term density, and density is one of those things that has a very fancy and specific definition. But before we get into that, you totally understand density because you've lived this many years. If I asked you to name some low density stuff, it's things like styrofoam, bubbles, clouds, pillows. I'm trying to think of something else off the top of my head. Air. All of those things are very, very low in density. High density materials are things that are very heavy for their volume. Bricks, gold, lead, copper, most metals, and a lot of rock happen to be high density. So you have a gut instinct about what density is. Here's the official definition. Density is defined as the mass in one unit volume of a substance. Now, this is the exact definition, and as in most definitions, you should know that for quizzes and tests. But how does this come into play, and how do we calculate it? Well, I'm going to go forward a little bit. Here's how we actually calculate this density. Density is a mathematical number, and it is a number that can be used to identify substances. Back in the old days when there were gold miners and people would bring in their ore that they dug out of the mine, and they wanted to know if it was pure gold or if it was fool's gold or something else. What would happen is they would take it into an assay office, and there a chemist would do a simple test. He would measure the mass of that rock or sample and measure its volume, and then divide the mass by the volume, and that would give him the density. Now, density is very, very useful for identification purposes. This is a list of densities as they are found as you go from the top layer of the Earth, the crust, down into the mantle, outer core, and inner core. The crust is the least dense. Okay, the top of the crust is less dense than the bottom. And as you go further and further and further down into the Earth, the inner core has the highest density, where the mantle, upper mantle, is less dense, and lower mantle is more dense. So let's go back a little bit, and let's go back to this layers of the Earth. The crust is the top layer. These are the mountains. These are the rocks that you and I pick up on the street. That is the low density material that makes up the Earth. Lower, below that, is a layer of what is called basalt. Basalt is a black rock that makes up most of the ocean floor, and basalt comes mostly from volcanic eruptions. In the center of the Earth is iron and nickel, and iron and nickel is very, very dense, very heavy for its volume, and also magnetic. Now, why is that a big deal? Later on, we'll talk about the Earth's magnetic field, and this is related to why we have a magnetic field. Now, part of this course, you are going to be asked to calculate density. So let's do an example problem. Density of a rock, let's say, has a mass of 56.3 grams and a volume of 4.4 cubic centimeters. So density is mass 56.3 grams divided by a volume of 4.4 cubic centimeters. Easy problem. I'm going to bring up my calculator, and if I go 56.3 divided by 4.4, I end up with 12.8, if I go down to 3 significant figures, grams per cubic centimeter. And that's the density of the rock sample that I have there. Now the question is, what layer of the Earth would this rock naturally occur on? Well, let's look. 12.8. 12.8, where is that in this list of densities? Well, that's down here. That's going to be an inner core rock that is probably made of iron, nickel, or something like that. So this simple test that we can do in a lab is really a wonderful tool in determining what you have and where it comes from on the Earth. That will complete this section. See you later.